Hi everyone. So today we're going to be looking at questions on standardized tests that use things that are familiar and they present them in ways that are unfamiliar. So today we're going to look at the difference of two squares and some approaches that might be a little bit more complicated and you might not necessarily see it so clearly. But in algebra, and Algebra 1 and Algebra 2, and you probably even used it in geometry, you learned about this very special factor pattern called the difference of two squares. I like to call it dots for short, dots. The difference of two squares is a relationship if I give you x squared, say, minus 25, and I ask you to factor it. Remember, factoring means breaking it apart into smaller pieces as a product. Well, that would factor to x plus 5 and x minus 5. Now, one of the things that you might have learned about is that the fact that if you multiply these out, you're going to get a positive 5x in the middle and a negative 5x in the middle, which is why when we factor or we multiply these, we don't get a trinomial, we get a binomial. So x squared minus 25 is the difference of two squares. I could make it a little bit more challenging by putting 4x squared, say, minus 25y squared. That is still the difference of two squares because both the terms are perfect squares. So it would factor to 2x plus 5y and 2x minus 5y. Okay, so how can we make this a little bit more tricky? Well, on the SAT, they like to give you multiple topics in one problem. So I'm going to look at, this is from Practice Test 2. So Practice Test 2, Math Non-Calculator number 7. Math non-calc number 7. And you know, when we get to number 7, we're starting to turn from a little bit easier to like a medium level question. And this particular problem I thought was very interesting. It gave us if x to the a squared all over x to the b squared equals x to the 16th, and x is greater than 1, and a plus b equals 2, what is the value of a minus b? Well, one of the things that stood out to me, number one, was that they gave me a plus b and they were looking for a minus b. And that is going to be one of the hints. That's like a hint for me because I had two expressions that were different and looked familiar. So I was like, okay. So this could be a situation where I'm using the difference of two squares. The problem is they gave you this expression which deals with the laws of exponents. The laws of exponents. The laws of exponents, when you are dividing numbers, that say that you can subtract the exponents. So I tend to always bring the smaller number to the larger number and subtract. But if I have a fraction and I don't know their values, I'm going to bring the exponent from the bottom up to the top. So I can actually rewrite this. It's an equivalent equation if I say x to the a squared minus b squared equals x to the 16th. All right, now this is an equivalent expression. So if these both are the same base, well, that tells me that a squared minus b squared equals 16. And there is that factor pattern that you're going to have to recognize on the standardized test. There is dots. All right, so if I factor a squared minus b squared, I'm going to get a plus b, a minus b equals 16. Well, they told me that a plus b was 2. And all they want is what a minus b equals. So I know that I'm looking for what number times 2 is going to give me is the same as 16, or is going to give me a result of 16. So a minus b would have to be 8. All right, guys, so that's a little bit trickier look at the difference of two squares. Now remember, think about what that hint might be. Did they give you any values that were, in essence, differences of each other or opposites? They're not really opposites, but they have one opposite term. So that's my hint that maybe it's dots. All right, have a great day.